Okay, it's time to talk exponents. We talked a little bit about exponents before and what an exponent means, but remember that if we have an exponent and we've got b to the n, then b is the base and n is the exponent. And the exponent tells you how many times to multiply the base times itself. So if we have 4 cubed, that would be 4 times 4 times 4, which would be equal to 64. Now you can do that on your calculator. Some of you have a little button, maybe it's a little rooftop button, so you take 4 and then you hit the little caret button and then 3 and you would get your 64 that way. Some of you may have an x to the y button, and it would be the same thing. You'd hit 4x to the y and then 3, that would give you the 64. Where you have to be careful on the calculators, if you have something like this 1/3, you have to know that because if you put a 1/3 in the calculator, a lot of times it's going to give you back a decimal, and we don't want a decimal answer for this particular problem. On a decimal, we would want a decimal, but not on a fraction. So what you need to recognize that this is 1/3 times 1/3, and you can multiply that out. 1 times 1 is 1, 3 times 3 is 9, so that would be 1/9. The 0.2 squared would be 0.2 times another 0.2. So if you multiply those out, then you're going to get 0.04. So you just need to know how to multiply those out. Sometimes it just is helpful. Alright, so you've got to be able to tell the difference in what happens with parentheses and without parentheses in an exponent, or a problem with an exponent. For example, if you've got -6 squared, the base is just the 6. The exponent is a 2. Now if you have parentheses around that -6, then its base becomes -6. So it's easier if we work some examples. The first one is just going to be 6 cubed, so that's 6 times 6 times 6, and if we figure that out, if we figure what that is, it is 6 times 6 is 30, or 36. 36 times 6 is 216. So now here's some with parentheses. So the way I say it in class is if you've got parentheses around a number, then the exponent goes with whatever's in parentheses. So if I have -6 squared, that means I'm taking -6 times -6 because that negative is in parentheses. So -6 times -6 is positive 36. Now, if I don't have it in parentheses, then what that negative is telling me is the opposite of. That's how I like to think of it. Okay? So that means the opposite of 6 times 6. Well, 6 times 6 is 36. The opposite of that is -36. So the negative carries to the answer. So the negative carries to the answer on this one. Alright, so if we have a negative cubed, -0.1 times -0.1 times -0.1. If I were to multiply all of those together, then you're going to get 0.001, and because I have a negative times a negative, that's positive. A positive times a negative gives me a final answer of negative. So on this one, the parentheses carried the negative with me, but I ended up with a negative answer. On a squared one, when I carried the negative with it, I got a positive answer. So you're just going to have to watch it. And we're going to learn a little bit about that, more about that in a minute. So this means the opposite of 0.1 times 0.1 times 0.1. So that's again 0.001, but the negative is on the outside, so it carries it to my answer. We got the same answer both ways. Well, if you have an odd exponent, you have an odd exponent with negative, then you get a negative answer. Okay? And then we'll learn about even exponents. I'll do that on the next page. Even exponents give a positive answer if they are in parentheses. So the parentheses makes a big difference. Negative 9 squared would be negative 9 times negative 9. Well, that gives me positive 81. See, I have an even exponent with a negative on the inside. I get a positive answer. Negative on the outside means the opposite of 9 times 9, which is 81, but the negative carries to my answer, so it's negative 81. Alright, so don't let parentheses throw you off. Be sure you take your time when you're doing those on your homework. Alright, so let's look at evaluating some expressions when we're given numbers on the inside, and we could have parentheses or not, it just depends. So on this one I've got x equals 4 for 7x squared. So 7 times 4 squared. Now, the 4 is getting that squared, not the 7, because there are no parentheses. Only the 4. I replace the x with the 4. So this is 7 times 4 times 4 is 16. So we're going to take 7 times 16 and we're going to get 112. Okay, that's going to be a little bit different from this next one. This next one starts with parentheses. So I have 7 times 4 in parentheses squared. So this time I need to do order of operations. I need to do parentheses before I do exponents. So that's going to be 28 squared, which is going to be probably a pretty big number. 28 squared gives me, relatively big, 784. So world difference with parentheses and not parentheses. Okay, so now we've got some x's and some y's. So 7 times 4 times negative 2, and that negative 2 is going to be squared. I need to do this parentheses first. So I'm going to take 7 times 4, then negative 2 times negative 2 gives me another positive 4. So 7 times 4 is 28. 28 times 4 is going to give me 112. If I have x plus y squared, then I'm going to have 4 plus a negative 2 squared. So here I need to do parentheses before I do exponent. So 4 plus negative 2 gives me 2 squared. 2 squared is 2 times 2, which is 4. Alright, so let's try this one. I'm going to write it out. You write it out on your paper, and let's see if we get the same steps. Watch your negatives on this one. Okay, I'm hoping that you put 6 minus a minus 4 in parentheses squared. You have double negatives because that's a negative 4. So that changes to 6 plus 4 in parentheses squared. You need to do the parentheses first, so that's going to be 10 squared, and then 10 times 10 is 100. Notice the difference between that one and then the one with the example over here. The example did not have parentheses, so it had 5 squared minus a minus 3 squared. So you had to do the minus 3 times minus 3 and get 9. So you had 5 times 5, which is 25. So 25 minus 9 is 16. A little bit different. You've got to watch your parentheses. It's so, so important. Alright, Now we're going to get into some rules with exponents. So exponent and I think at the end of this chapter it's going to give you a box where it summarizes all of these rules. My advice is to get a note card, and as we go through the rules from each section, write them down on a note card so that you have them. So the first thing is the multiplication rule of exponents. When you have x to the 2, no, I think they're going to do it with m's and n's. X to the m times x to the n equals x to the m plus n. When you multiply, you add your exponents as long as you have the same base. Common means same base. So I can only add the exponents of the bases of x or the bases of z. So in this example, I've got 7 to the z times 7 squared. Well, that's going to be z to the 5 plus 2, which gives me z to the 7. Okay, same base. 4 to the 5th times 4 squared, 4 to the 5 plus 2, which gives me 4 to the 7th. And then if you need to work it all the way out, that's one that I'd probably pull out the calculator for. 4 to the 7th power equals 16,384. Pay attention to your directions. If it told me that I could leave my answers in exponent form, then I would have just left it as 4 to the 7th. So here's the rule that I'm working on. You add your exponents if you multiply like bases. So here I've got x to the 5th y squared. Those are not like bases. So you can't do anything with it. X to the 5th y squared. That's as simplified as it gets. Alright, here I've got m to the 6th, m to the 9th, and an m. And if there's no exponent, there's an imaginary 1 there. So I'm going to have m to the 6th plus 9 plus 1. So that gives me m to the 6 plus 9 is 15 plus 1 more is 16, m to the 16th. So when multiplying bases, we're going to add exponents, and I want to say, I'm going to put in here like bases. Okay? They have to be alike. Alright, so b to the 5th, b to the 7th, b to the imaginary 1. You write down what you think it is. I'm going to be quiet for a second and just write. And I got b to the 13th when I added those. Alright, now, second rule. When you divide like bases, you're going to subtract your exponents. So when we multiplied, we added our exponents. Now we're going to do the opposite. When we divide, we subtract. So if I've got x to the 8th over x cubed, 8 minus 3 gives me x to the 5th. 2 to the 11th over 2 cubed gives me 2 to the 11th minus 3, which is 2 to the 8th. And if they ask for a final answer for that one, then that would equal 256. A lot of times with the numbers, you can go ahead and work them out. With the variables, you have to leave them like they are. So when dividing by like bases, subtract the exponents. So s to the 10 over s to the 5th. So that's s to the 10 minus 5, which would give me s to the 5. Alright, now let's kind of do some combining of the two rules. Remember, when we multiply, we add the bases. When we divide, we subtract. So a lot of times what I like to do, if I have one with it's a combination, I'll do the numerator of the fraction, I'll do the denominator fraction, then I'll save the subtraction for the end. So here I'm going to do the top, t to the 4th, t to the 9th, that gives me t to the 9 plus 4 gives me 13 on top. There wasn't anything to do to the bottom, it's a t squared. So now 13 minus 2 gives me t to the 11th. Now on this one, I can not do anything with the numerator, it stays an 8 to the 11th. But on the bottom, 8 squared times 8 to the 5th, 2 plus 5 would give me 7. And then we could subtract these. 11 minus 7 gives me 8 to the 4th. And then if I want to work out what 8 to the 4th is, that's going to be equal to 4,096. So you see, they're not bad. The rules are not bad. Again, it's helpful if you put these on a note card, so you have the note card in front of you when you're doing your homework and you're not having to flip back to look at the rules. Okay, so on this one, let's do the numerator. B to the 5 plus 7 gives me B to the 12 over B cubed. Then I'll do my subtraction. 12 minus 3 gives me B to the 9th. Alright, more expressions. So I need to remember to follow my please excuse my dear Aunt Sally. No matter what math class you're in, you're always going to go back to PEMDAS or please excuse my dear Aunt Sally. You just can't get away from order of operations. So let's do some of these. In this case, I'm going to clean up. If there's anything to clean up in the parentheses, then I'll do that. If there's multiplying, then I'll multiply numbers, then I'll take care of variables and add their exponents, or subtract if I'm dividing. So here I've got a 6 times a negative 2, so that gives me negative 12. And then I have an x cubed and an x to the 1, so 3 plus 1 would be x to the 4th. And then I have a y to the 7th and a y cubed. 7 plus 3 would give me y to the 10th. So multiply to my numbers, because this is not a subtraction problem because I have 2 parentheses. Multiplied my numbers and then added the exponents in my variables. Alright, let's look at this fraction. 15 over 20. Can't divide that completely, so I just have to reduce it. 5 goes into 15 3 times. 5 goes into 20 4 times. So I know I'm still going to have a 3 and a 4 left in my answer. Alright, let's look at the a's. I've got a to the 5th over a to the 1. 5 minus 1 would be 4, a to the 4th. For the b's, 7 minus 6 is 1, so a b to the 1, or you don't have to write the 1, you could just write a b. So this could be written also as 3/4 a to the 4th b. Just make sure that that a to the 4th b is either out to the side of the fraction or with the numerator. Do not try to put those with the denominator because that's a completely different answer. Okay, let's try this one. 6 times negative 2 is going to give me negative 12. X cubed, and then an x to the 1, 3 plus 1 would be x to the 4th, y to the 7th, and a y cubed, 7 plus 3 gives me y to the 10th. Okay, I'm going to write the next one quietly. You do it on your paper, and then you look back and check your answer. We've got 14x to the 5th, y to the 6th, 21x to the 4th, y, and I'll go ahead and put a y to the 1 there. So I'm going to reduce it and write my answer, and you do it the same, and then look back and see if we got the same thing. Alright, let's see if we got the same thing. I reduced my 14 over 21 by 7s. So 14 divided by 7 is 2, 21 divided by 7 is 3, so I know I have a 2 over a 3. Then on my x's, 5 minus 4 gives me x to the 1. You don't have to put the 1 there, you could just put an x. And then y to the 6th over y to the 1, 6 minus 1 would be y to the 5th. Did you get the same answer as I did? I hope so. Okay, let's look at this last page. These are simple interest problems. We are not going to have to do any of these in our homework. I'm just going to work it real quick just to show you if you have it later on in another class. P always stands for principal, R is rate, T is time. This is an interest problem, so I stands for interest. So your 5,000 is the principal is always the money you invest, so or the money you put in. So that'd be 5,000. You have 4% interest, so you need to have that as a decimal. You know, anytime we work problems with percents, we need to change them to a decimal. Determine the amount in the account after 1 year, 2 years, and 20 years. So interest after 1 year, so my T would be, this is T each time. So this is really 3 different problems. So principal would be 5,000 times my interest, 0.04, times 1 year. You just have to multiply your 5,000 times 0.04, and that gives us $200 that we would earn in interest after a year. Okay, so let's see what happens after 2 years. 5,000, we're still at the same interest rate, but this time times 2. So 5,000 times 0.04 times 2. So we're going to make $400. Okay, let's see what we would make after 20 years. This is good to know if you have a savings account, if you have any kind of account where you're drawing interest. Times 0.04 times 20 years. I would think we're going to make quite a bit of money. 5,000 times 0.04 times 20 years, we make $4,000. We almost double our money. That's how we use percents. Y'all have a wonderful, wonderful rest of the day.